Hey there, welcome back to another episode of Algebra in Words. Tonight we're going to go over more of the basics that involve ones and zeros in fractions, exponents, and radicals. These are important because these are some little nuances that you're going to need to know and be able to fluidly use to go forward that you'll need later on, alright? And there's probably a few little details in here that you may think you know, but maybe you just need to sharpen up on. So that's what I'm going to do with you today. Alright, so all we're going to do is go from top down, left to right, and just go over each little mini problem, and I'm going to explain it. Alright? Everything that I'm going over in this episode, you can also read in words and follow along with in my book, Algebra in Words. And these topics are covered from page 10 to 20, all right? The link to this on Amazon is in the description box below. Okay, so let's start here, where we have 1 over 1. That's pretty easy. 1 over 1 is equal to 1. But let's make sure we know why. It's because any numerator divided by 1 equals the numerator. Alright, and in this case it's 1 over 1. So whatever this is, if it's over 1, it equals what the top is, which is 1. If we had 3 over 1, it would be equal to 3. I'm sure many people know that. Okay, then let's go to the next one, 0 over 1. The answer to that is 0. And the reason is for the same reason as the last problem, because anytime that you have a number over 1, it equals the number on top, which in this case is 0. Let's go to the next one. We have 1 over 0. Alright? And the answer to 1 over 0, if you want to think about it first for a second, the answer is undefined. I'm just going to write that abbreviated. Why is it undefined? The answer is because basically you can't divide any number by 0 to get an actual number or a real number. Alright, one little quick thing I want to point out is, and it's a good thing to test on your calculator or your phone calculator, do 1 divided by 0. And if you do that, you should notice that your calculator will say error. Okay, when your calculator says error, that's the calculator's way of saying undefined. Alright, so if you do it on a test and you get error, write undefined. And what about 0 over 0? Alright, let's pause a second, and there's a reason why I have this problem up. Because when we look at a problem like this, usually you think to yourself, and I kind of forgot to explain this aspect, but whenever you have 0 divided by any number in a fraction, the answer is 0. So for example, if we had 0 divided by 10, or 0 divided by 55, the answer would be 0 because 0 is in the numerator. But there's one exception to that, and that exception is here. 0 divided by 0 is undefined. And why is that again? Because you can't divide any number by 0, even if 0 is in the top. So again, just to summarize the points here, is that 0 can be divided by any number except for 0. 0 divided by 0 is undefined because you can't define any number by 0 even if 0 is in the top. So that's a very important thing to remember. That slips through the cracks for a lot of people. That's why I cover this in my episode. Okay, let's now go to some simple exponents involving 1 and 0 and also some squares. This one is 1 to the power of 1. Now, oftentimes, from here on out, usually if the exponent is 1, it's not written. It's assumed to be 1. Any factor or any term can be assumed to be automatically to the power of 1, and it's never written. But nevertheless, 1 to the power of 1 equals 1. Okay, pretty easy. The point to this is any base raised to the power of 1 equals the base. So if this was 6 to the power of 1, it would equal 6, and so on. Okay, let's go to the next one. 1 to the power of 0. The answer to 1 to the power of 0 equals 1. Alright, and let me do the next one before I kind of explain it. 2 to the power of 0 also equals 1. Why does 1 to the 0 and 2 to the 0 equal 1? Because any base raised to the power of 0 equals 1. There's one exception to that, and I'm going to go over that shortly. Okay, what about when we have 2 to the power of 1? Well, just like I was saying a minute ago, when you have any base raised to the power of 1, in this case it's base 2 raised to the power of 1, it equals the base, which is 2. Okay, let's go to the next one. 0 raised to the power of 1. The answer is 0. Why is it 0? Because this is another principle in which anytime the base is 0 raised to any number, the answer is going to be 0. There's one exception to that, which I promised I would get to. We'll do that one next. And to summarize this, any base raised to the power of anything equals 0. The next one is the exception. What about 0 raised to the 0? Do you know what that equals? It equals undefined. If you want to test that on your calculator, again, you can hit 0. Every calculator is a little bit different. If you have the caret to do exponents, then do 0 raised to the caret and then 0. You'll get error, and that means, again, undefined. So to summarize this point here before we go on to the next line, it's that anytime that you have base 0 raised to any power, the answer is 0, with the exception of when you have base 0 raised to the 0. Okay, that's undefined for basically two reasons. You can't take 0 to the 0, that's undefined. But I want to point out one last thing, which I promised a second ago. This is also the exception to the rule of raising any base to the power of 0. Normally, people just kind of generally remember it as any base to the 0 is equal to 1, right? 2 to the 0 equals 1. 8 to the 0 equals 1. That's true unless the base is 0. 0 to the 0 is undefined. So you just need to remember that. That's just one of those rare exceptions. Probably won't come up on many tests unless it's 0 to the 0. Okay, let's go on to the next one. These are going to be dealing more with squares now and a little bit higher exponents, but I'll explain. So first we have 1 raised to the 2. We say 1 squared. That equals 1. Why is it 1? Well, anytime that you have a base raised to any power, it equals 1. We saw that here, and also I think that's good enough. 1 to the power of any exponent is equal to 1. Alright, so let's go to the next one. The one little statement I wanted to make about this is 1 to the power of... Actually, I think I made the statement. I'm getting ahead of myself. I'll come back to that. Next one is negative 1 raised to the power of 2 or squared. Okay, the answer to that is 1. It may not seem like a big detail, but it kind of is. Let me explain why. Notice that the negative, first of all, there's a negative. Secondly, the negative is inside the parentheses, okay? The point that I want to make about this is anytime that you have a negative base in parentheses raised to any even power, it could be 2, it could be 4, it could be 8, any even power, the answer is always going to be positive. Okay, why does that matter? Because, or why does that happen? Because if you think of exponents as the number of times you're multiplying the base times itself, every time you multiply a negative times a negative, you get a positive. So every time that you have a negative times a negative, and every repetition of those duplicates, it's always going to come out to be positive. So again, the take-home point from this is that any negative base in parentheses raised to any even power is going to equal a positive number. In this case, it was 1. Okay, this one we have negative 1 squared. Notice the difference between negative 1 in parentheses and negative 1 not in parentheses. I'm going to save this one for the end. While we're going through this, maybe pause it or think about what is negative 1 squared. Okay, think about if the answer is negative or positive. If you're not sure, again, I'm going to save that for the end. We'll go over that. Let's then look at 1 cubed. The answer to 1 cubed is 1. For the same reason as these others, anytime you have base 1 raised to any power, it equals 1. Nothing big surprising there. All right, let's look at negative 1 in parentheses cubed. All right, the answer to that is negative 1. Why is it negative 1? Because this example exemplifies the principle that anytime you have a negative base in parentheses raised to any odd power, you're going to get a negative answer. And again, if you think about it, because the exponent means how many times you multiply the base times itself, if you have a negative times a negative, it's a positive. But then anytime that you have another negative thrown in, when there's an odd number of negative factors, it's just always going to equal, I forgot to write the negative, it's always going to equal a negative answer. Okay? I'm going to do this one after I do this one, because I want to make a couple points on that. All right, let's go to the next one. Now we're dealing with radicals. Okay, just to remember the basics of radicals. You have the root, which is written here, and you have the radicand, which is written underneath in the symbol. I go over them a little bit more in future episodes. But anyway, what is the square root of 1? The answer is 1. All right, 2 points I want to make on this problem. The first one is, notice that I have the root 2 written here. I only did that for exemplary purposes, but normally, from here on out, you should just remember that anytime you don't see anything written there, you should assume that the root is 2, the square root. Notice in this one, and this, and this, there's no number 2 written. That means it's assumed to be square root. All right. Also, any root of 1 equals 1. So this is the square root, root 2. You could have the cube root. You could have root 4. You could have root 800. Any root of 1 is always going to equal 1. What about when you have 0 in the radical? Any root of 0 equals 0. Okay, let's move on to the next one. We have the square root of negative 1. Okay? For now, especially if you're in the early stages of algebra or in the beginning of the book, for now you could say no solution or undefined. A better answer is no real number. A better answer is no real number. Okay, once you get a little more advanced, you're going to start to convert the square root of negative 1 into I for imaginary number. But again, imaginary is just kind of the opposite of real. So, the long story short, you can't take the square root of a negative radicand. But if you want to generalize that more, you would say you can't take any even root of a negative radicand. So if it's the square root, if it's the 4th root, the 6th root, the 8th root, the 12th root, the 100th root, any time that the root is even and the radicand is negative, you can't do it unless you factor in imaginary numbers. All right, so in the beginning stages, if you had it on a test, say no real number. That's the best answer for the early stages. I'll go over factoring in imaginary numbers and complex numbers in later episodes. Okay, what about this one? It's the square root of 4. And again, for the early stages, you might just want to say 2. The best answer is, and I'm going to write the best answer plus or minus 2. You'll get into those details a little more later. But for now, the bigger point here is that the radicand is positive. So we can take an even root of a positive radicand. The 4 happens to be a perfect square, meaning that the answer is a non-decimal, non-fractional number. I probably don't get too much into real numbers and rational and irrational and things like that. The books usually explain that pretty well. But again, the point is, you can take the even root of a positive radicand, and this little problem exemplifies that. That brings us to the next one. It's the square root of negative 4, which ties back to the square root of negative 1, which, remember, is used to point out that you cannot take the even root of a negative radicand. The square root of negative 4 is also the even root of a negative radicand because the 4 is negative. So for now, you could just say no solution or no real number. All right? Let's go down to the last line. Hopefully you can see it. If you can't, it's the cube root of 0. I think you can see it. The cube root of 0 equals 0. Why is it 0? Because any root of 0 equals 0. That's pretty much all there is to that. Just like the square root of 0 is 0, any root of 0 equals 0. Okay, let's go to the next one. The cube root of positive 1 equals positive 1. I'm just going to write 1. The cube root of 1 is positive 1. All right? Let's go to the next one, the cube root of negative 1. And the answer to that is negative 1. Okay, let me pause there because I want to compare the cube root of negative 1 to the square root of negative 1. All right, if you remember that the square root of negative 1 is no real number, okay, don't confuse that with this one. We can take the odd root of a negative radicand, okay? And that's what this problem exemplifies, because 3 is an odd number. So if you had 3, if you had 5, if you had 7, any odd root of a negative radicand, you'll result in a negative answer, okay? A real solution, a negative answer. What about if we look at the cube root of negative 8? Well, 8 itself happens to be a perfect cube, and it's negative, and we can take an odd root of a negative radicand. So the answer to this is negative 2. The cube root of negative 8 is negative 2. And finally, at least before we get to the last two I saved, is the fourth root of negative 1. Think about that a second. What is negative 1 to the fourth root? All right, the answer to that should be no solution, or no real number. Why is it no real number? Because again, this is an even root with a negative radicand, and you can't take the even root of a negative radicand. I just put that in there for practice. All right, so let's get rid of some of this clutter. And focus on negative 1 squared. Okay, I want you to think about that. Is the answer going to be negative 1 or positive 1? And why do you come to that conclusion? All right? The answer to the question is negative 1. Why is it negative 1? Well, believe it or not, order of operations is a very key player and a key reason to why it's negative 1 and not positive 1. All right? And here's the reason. Think of negative as negative 1 times 1 squared. All right? And that's not in parentheses. So you should really think of it like this. Okay? And notice how I have the negative 1 and this 1 split up. What's the order of operations? Well, it's exponents first, right? All right? There's nothing to simplify in each individual parentheses, but exponents you would do next. And 1 squared equals 1. But then we didn't really apply the negative 1 multiplication times 1 squared yet. So I'm going to write the negative 1 here. Negative 1 times positive 1 is negative 1. So to summarize that, negative 1, the base negative 1, not in parentheses, squared, is equal to negative 1. Alright? Also, any negative base raised to any even power is going to equal a negative when it's not in parentheses. When it is in parentheses, which you can go back earlier in the video to see, any negative in parentheses raised to an even base will equal a positive number. Alright? And that brings us to the final problem, which is, what is negative 1 cubed? Alright? The answer to that is negative 1. There's not really much else to say about it, but again, we're going to apply the same principle, which is break up the negative and the base 1, and then cube the 1. 1 cubed is 1, and then 1 times negative 1 is negative 1. Alright, so the reason why I wanted to do that one last is not as a trick, but basically just to get you thinking, because throughout this video we went over a bunch of different situations and exceptions where the even or the odd of either the exponent or the radical affected the sign. And so I just wanted to give you one to think about with regards to when the base is negative for an odd exponent. So that's all I have for this particular video. We'll go over some more examples in other videos. But anyway, thanks for watching. Remember, if you found any of this video helpful, please give it a like. Remember that everything that we went over is in a more organized written form in my book, Algebra in Words, between pages 10 and 20. Please subscribe to my channel so that you can get alerts for future videos, and please share with your friends if you found this helpful. Also, remember that I have other videos on Facebook and Instagram. So thanks, and I'll see you next episode. Bye now.